Okay, we're in the home stretch for lesson 60. We're in the home stretch for lesson 60. This is the last part of this lesson. We are going to look at confidence intervals and find the point estimate and the margin of error, and we're also going to talk about how to interpret a confidence level. So for finding the point estimate, we need some formulas. Our confidence interval will be written as a range of values. So we'll just use the notation lower bound, comma, upper bound. So LB and UB. If you want to find the point estimate, which can be abbreviated PE, you want to find the middle of this interval because that's what this interval is made from. It's made from your point estimate. So in the middle is your point estimate. So you would take your lower bound plus your upper bound and divide that by 2. That's going to give you the value that your confidence interval was based off of. If you are asked to find your margin of error, well, that's the distance between your point estimate and the end point. So what you would do is take your upper bound, subtract your lower bound, and divide that by 2. So one of them you add, divide by 2. The other one you subtract, divide by 2. So let's look at an example to see what would be expected of us in this situation using these formulas. A 90% confidence interval for the proportion of students at Cypress High who will cheat on homework is 0.67 to 0.81. So here's what happened. We took a sample of Cypress High students. We don't know how many people are in the sample because it didn't tell us, but we took a sample and calculated p hat. Based off of that p hat, we have this confidence interval. What this confidence interval says is that the true proportion of students that will cheat on homework is between 67% and 81%. We're 90% confident that's true. So the reason that there's P there is because we're expressing that we think that P, the true proportion, is in this interval. So they want to know, well, what was the point estimate that you got from your sample? Well, point estimate in this case is P hat. And to find P hat, we take our lower bound, 0.67, plus our upper bound, 0.81, and we divide that by 2. That gives us a point estimate, or a P hat, of 0.74. So we took a sample of Cypress High students, and our sample resulted in 74% of them being willing to cheat on homework, or that will cheat on their homework, which is probably true depending on your definition of cheat. Sometimes I think you guys think you're helping each other when really you're just copying each other's work. So this seems pretty accurate to me. Okay, well, what's our margin of error? What is our margin of error, or what is our, in this case, what's our 2 sigmas? Or our 1.5 sigmas, or whatever it may be. Well, to find our margin of error, which is our standard error of p hat, we would do 0.81 subtract 0.67 divided by 2. This gives you 0.07. So we take a sample of Cypress High School students. We find the proportion that will cheat on homework. That was 74%. How much might we be off by from the true value? 7%. So our sample value is 74%. We could be off by about 7% from the true value. So 7 below and 7 above. That's a pretty big margin of error. So I'm going to say that all one more time. We took a sample and we calculated the proportion that will cheat on homework. That proportion was 74%. And based on our confidence level and our sample size, we think that we're off by about 7% from the true value. Or we could be off. Not we are. We could be off by 7%. That is how your confidence interval was built. 7% below 74 is 67, and 7% above 74 is 81. So our confidence interval is any value between 67% and 81%. Okay, next up, it's asking us to interpret confidence level for this question. And I want you guys to highlight the fact that they're asking for confidence level. Down below in the next question, they're asking us to interpret the confidence interval. Those are two separate things. Remember, confidence interval is we're 95% confident that this interval captures the true value. Confidence level, though, is how many times did our samples capture the true value. I know that that sounds very similar, but I think once we look at the interpretations, hopefully the difference will become more clear. So here's how you interpret confidence level. And remember, in this problem, it was 90%. If this sampling procedure, so sampling procedure is just if we took these samples many times. So if this sampling procedure were repeated many times, about 90% of the resulting confidence intervals will capture the population proportion of students who will cheat on homework. The key phrase in here is many times. If we took many samples and created confidence intervals for each sample, 90% of those will result in a confidence interval that captures the true value. So if this sampling procedure were repeated many times, about 90% of the resulting confidence intervals will capture the true value. This is exactly what we were looking at here. 96% of our confidence intervals captured true mu. How many times was our sampling procedure repeated? 25 times. So if the sampling procedure were repeated many times, so you take many samples of size 20 and you calculate the mean for each one, about 96% will capture true mu. To interpret confidence interval, you are specifically talking about one interval that you have found. This one is saying how many of your intervals will capture the true value. This one is saying how certain are you that your interval captures the true value. Okay, so 2 says 2 weeks before a presidential election, a polling organization asked a random sample of registered voters the following question. If the presidential election were held today, would you vote for candidate A or candidate B? Based on this poll, the 99% confidence interval for the population proportion who favor candidate A is 48% to 54%. Interpret the confidence interval. So you are using this box. So pause the video and use mine that I have here to write your confidence interval. Go. Do it. Pause the video. Interpret the confidence interval. Okay, hopefully you really did it, because now I'm going to show you mine. We are 99% confident that the interval from 0.48 to 0.54 captures the population proportion who favor candidate A. And notice here, I highlighted the wording, the exact wording that I should use in my interpretation. You have to have everything that mine has. You cannot be missing anything. Going through your guys' first packet on confidence intervals, some of you guys left this out. What this is referred to is context. This is referred to as context. And if you leave the context out of your responses, you 100% for sure do not get full credit. One of the most important things in AP statistics is to add context. So make sure that this context is in your interpretation. You can't leave any of it out. So speaking of, in the problem with the divorces, when you add context for this, like you literally need to say this big old long sentence. Couples that will have a child within the first 2 years of marriage and will divorce within 5 years. Some of you guys just left off the end and said couples that will have a child within the first 2 years of marriage. You gotta include all of the context, family. I know that it's so annoying and cumbersome, especially when you're practicing because you're doing it over and over and over again. Like, I truly feel you. I have sympathy because I do it too. I do the same homework that you do. I do it every year and it's not fun, but it's necessary to be successful. So make sure that you have this context in there. Okay, next up, you find the point estimate and the margin of error. So pause and you really calculate point estimate and margin of error. Okay, I have that the point estimate was 51% and our margin of error is 3%. So what does that mean? This sample that was taken, it says 2 weeks before the presidential election, a polling organization asked a random sample of registered voters, if it were held today, who's in favor of candidate A? 51% of that sample said they were. Based off of our confidence level and that sample size, we can say that we're off. We could be off by about 3%. We could be off from the true value by about 3%. This is based off of your sample size and confidence level. Okay, what's up next? Oh boy. Okay. Okay, Famil. We're going to do the next one together. So, based on this poll, a political reporter claims that the majority of registered voters favor candidate A. Use the confidence interval to evaluate this claim. So, we've been playing pretty loosey-goosey on on evaluating a claim. And now we need to start being really careful about how we evaluate a claim, especially as we move toward the next unit, because the whole unit is on evaluating claims. So, when we evaluate a claim, we are looking for evidence to reject the claim. We are not looking for evidence to support the claim. We're not looking for evidence to support. The only thing that we're looking for is evidence to reject, evidence against the claim. So we never use it to say we support this claim. We only use it to say we reject this claim or we do not reject this claim. Do not reject is not the same as support. So we have to frame our answer based on whether or not there's evidence against the claim. So the claim in this case is that P is greater than 0.50. So a majority would be anything above 0.50. It could be 50.1, and that's a majority. Well, our confidence interval includes values above 0.50. Our confidence interval includes 51, 52, 53, and all of the possible percentages in between those numbers. So any percent between 50 and 51 is included. So do we have evidence to say that this is not true? Well, no, we don't, because we have values in our confidence interval that are above 0.50. That's what this response is addressing. Any value from 0.48 to 0.54 is a plausible value for the population proportion P that favor candidate A. So 51 is a plausible proportion. 52 is plausible. 53 is plausible. 54 is plausible, and those are all a majority. Because there are plausible values of P, more, so you have to change this word to more, than 0.50, the confidence interval does not give convincing evidence against the reporter's claim. I left these in intentionally because I want you to know or have a reminder that we do not use our confidence interval to support a claim. We are only going to use our confidence interval to say if we have evidence against a claim. Evidence against. Okay, family, this one was a doozy, but necessary. So, this page, if you check below, these questions are included in your lesson quizzes. So, I think that it is helpful to have some record of those lesson questions because a lot of them are useful. So in this case, I took these questions and converted them to a lesson quiz. I did that for all of them except E. So the last thing that I want to talk about, and I will try to keep it very brief, is part E. So as part of a school project, Ellery surveyed a random sample of 25 students from her school, and one of the questions in the survey required students to state their GPA aloud. Based on the responses, Ellery said she was 90% confident that the interval from 3.14 to 3.52 captures the mean GPA for all students. Well, I have several independent study classes, and I can look up their GPAs. In fact, I often do because I'm trying to see if they have things to work on. I could look up all of your GPAs, and I'll tell you what. In any of my independent study classes, the average GPA ain't nowhere near 3.14. It's just not. In fact, several of my independent study kids have a GPA that is less than 1. Less than 1, family. So this, I don't know what school she goes to, but this is not true for our school. Why is it so high, though? Well, either Ellery is at a private school and everybody's living their best life, or these kids are lying. These kids are lying about what their GPA is. Well, why might they do that? If I had a low GPA, I might be embarrassed. If I had a 2.5 GPA, I don't think that I would be super excited to say out loud in front of other people, 2.5. I would feel okay if I was like 3.8, 3.5. But if my GPA is a 2.5 or a 2.0, I might be embarrassed about that GPA, and so I lie and say that it's higher than it really is. So down here it says, describe one potential source of bias in this study that is not accounted for by the margin of error. Well, what the margin of error accounts for is sampling variability. Accounts for sampling variability. So what is that? What is sampling variability? Well, sampling variability is this idea that all of our samples are going to be different. So based off of the idea that all of our samples are going to be different, by how far off might we be? Because I know that my sample is probably not equal to the true value because every sample is probably different. So how far off am I? That's what margin of error accounts for. So what could be some other bias or some other errors in her study? Well, these students might lie. Why might they lie? Maybe they're embarrassed about their GPA. Maybe they don't want to share their GPA with everybody. So there are going to be times where we have errors in our information that have nothing to do with mathematics and have everything to do with people and how people behave and choices people make. So I think that that's a really good idea to talk about, because the last unit we do right before we take your AP exam is a unit on sampling and things like this, sample bias. I mentioned that these are in the lesson quiz and that sometimes it's good to have a record of what those questions were. What I meant by that, or where I was going with that, is you can fill this out if you want to. And if you don't, that's okay. I'm not going to check it. I personally think that it would be good to write it down, especially C and D, but like I said, I'm not going to check it. So you decide what works best for you. Okay, that's it. You survived. I, at this point, would often say I'm sorry that this was so long, but guess what, family? Class is an hour and a half long. Sometimes our lessons are long, and that's just life. And I appreciate you making it through, and I love you, but I can't be sorry anymore, because it just is what it is, okay? Okay. So, if you need any help, you email me, you come see me. I'm happy to help you. I'm happy to help you. Okay. Love you.